The universe seems to be endless with no signs of life. While a lot of us might believe there is no extraterrestrial life out there, no one can prove otherwise. But recently, scientists made an incredibly shocking discovery when looking at the second planet from the Sun, Venus. They claim to have found life. But how is it possible that we haven't detected life before on Venus until now? And is there really life on Venus? Venus is an incredibly hot world, but research seems to suggest it once had vast oceans. It's possible that Venus could have been as habitable as the Earth, but in the last billion years, greenhouse gases transformed the planet from an oasis to the uninhabitable hell it is now. The scorched surface becoming too harsh for life forms that may have retreated deep into the ground or into the atmosphere to avoid extinction. In order for us to look at the possibilities for life on the planet, it's interesting to know a little bit about Venus and its evolutionary history. Chances are you've seen the planet Venus many times and didn't know it. You can easily see it from Earth because it's the brightest object in the sky next to the Sun and Earth's moon, and it's visible as a bright star in the morning and evening sky. It's one of only 4 terrestrial planets in our solar system and considered the Earth's sister planet. Venus is about 20% smaller than Earth and is smaller inside with an iron core 2,400 miles wide. We can't see the surface of the planet from Earth because Venus is covered with thick clouds. But there have been space missions that show it's covered with mountains, volcanoes, craters, and huge lava plains. And for the record, those spacecraft didn't last long. This is because temperatures on Venus are hot enough to melt lead at around 880 degrees Fahrenheit, hot enough the ground would glow a dull red. The atmospheric pressure at the surface is 92 times the sea level pressure on Earth, or the same as being 3,000 feet underwater. It would crush you, and any spacecraft not built to withstand the immense pressure. The thick clouds are mainly carbon dioxide, but also have a layer of reflective sulfuric acid with the smell of rotten eggs. It's not a place you would want to be, or could survive more than a few seconds. Venus is too close to the Sun to sustain life as we know it, and averages a distance of about 67 million miles away from the Sun. However, about 3 billion years ago, the Sun was only 80% as luminous as it is now. With that in mind, it's possible that this hellish planet could have had an environment much like the Earth. And for about 2 to 3 billion years after the planet formed, life could have had plenty of time to emerge. The Pioneer Venus spacecraft launched by NASA in 1978 and several other space explorations have helped us study the planet and reveal some details on how it transformed from an Earth-like planet to the hellish place it is today. Evidence was found showing there may have been shallow oceans on the surface of Venus for 2 to 3 billion years, and temperatures on the planet would have ranged from a low of 68 degrees Fahrenheit to a high of 122 degrees Fahrenheit. It would have been easy for life to flourish under these conditions, and where there is water, there is a good chance of life. Ancient Venus was certainly a lot different than it is now, and it's been theorized that it formed out of ingredients similar to Earth, but followed a different evolutionary path. Its rotation rate around the Sun is 117 days compared to Earth's 1 day. But scientists say it's possible Venus once had the same rotational period as Earth. It had more dry land than the Earth, especially in the tropics, and the surface was ideal for making the planet habitable with plenty of water to support an abundance of life, and there was plenty of land to reduce the planet's sensitivity from incoming sunlight. But around 700 million years ago, some kind of massive resurfacing event triggered a runaway greenhouse effect, causing the planet's atmosphere to become very dense and very hot. No one knows for sure what caused this massive catastrophe to happen, but some researchers believe that volcanic activity may have been the cause, as magma and molten rock bubbled to the planet's surface, releasing huge amounts of carbon dioxide trapped in the planet's crust when it rapidly cooled after forming 4.2 billion years ago. This sounds like a scary occurrence, and similar events have happened here on Earth. The Siberian Traps is a huge 3 million square mile region of volcanic rock in Siberia, Russia. It's the evidence of a massive eruptive event that happened in the last 500 million years. The 2 million year eruption released toxic amounts of greenhouse gases and caused a mass extinction. So now that we know quite a bit about Venus, could simple life forms be struggling to survive on the planet after millions of years? And how would we know? Recently, scientists say they've discovered a chemical called phosphine in the clouds of Venus. Phosphine is made up of 1 atom of phosphorus and 3 atoms of hydrogen. It's also been detected here on Earth, on Jupiter and Saturn. So, how is this discovery of phosphine evidence for life? The one thing that got researchers excited about the smelly flammable gas is that, as far as we know, phosphine can only be made by life, whether it be humans or microbes. Humans have made it to use as a poisonous chemical weapon that was used in World War I, and it's still made as an agricultural fumigant. But the interesting thing is that phosphine is also made naturally by some species of anaerobic bacteria. These are organisms that survive in oxygen-starved environments, such as landfills and marshlands. With that in mind, researchers set out looking for phosphine on other planets, since finding it could indicate the presence of alien metabolisms, and they found it in the clouds of Venus. Using the largest astronomical telescope in the world, the James Clerk Maxwell Telescope and the Atacama Large Millimeter Array Telescope, researchers measured trace gases in the Venus atmosphere. Phosphine should not be in the Venusian atmosphere at all. It's extremely hard to produce, and the chemicals in the clouds should destroy the molecules before it can accumulate in amounts large enough to be observed. So, what could be creating the phosphine? Some scientists say it's too early to conclude life does exist on Venus, and that the data needs to be verified, and the phosphine fingerprint could be a false signal introduced by the telescopes or data processing. But if phosphine is really floating through the clouds on Venus, it suggests one of two things. Alien life forms are linking together phosphorus and hydrogen atoms, or there is some completely new chemistry that we don't know about that's creating phosphine in the absence of life. Despite the sulfuric acid in the clouds of Venus, they also carry the basic ingredients for life as we know it: sunlight, water, and organic molecules. And scientists have speculated for nearly 60 years that life could possibly exist on the planet. Near the middle of the cloud layer, temperatures and pressures are nearly Earth-like, and there are molecules in the planet's air that alien microbes could metabolize. The possibility of finding bacterial life in the clouds of Venus is important, because the earliest evidence of life on Earth comes from fossilized mats of cyanobacteria called stromatolites in Greenland, which are around 3.7 billion years old. But the fact that life could live in such extreme environments is something we already know about. Around 4 billion years ago, there lived a microbe called the last universal common ancestor, or LUCA. There is evidence that this microbe lived an alien lifestyle because it was hidden deep in underground iron-sulfur-rich hydrothermal vents. Being both anaerobic and autotropic, it didn't breathe air and made its own food from the dark, metal-rich environment it thrived in. This microbe's metabolism depended on hydrogen, carbon dioxide, and nitrogen, which it turned into organic compounds such as ammonia. The most remarkable thing of all was this tiny life form was the beginning of a long lineage that covers all life on Earth. Now that the biosignature of phosphine gas has been discovered in the clouds of Venus, there are missions being planned by several institutions, including California's Rocket Lab, who plan to send a spacecraft to Venus in 2023 to hunt for definitive signs of life. The mission will use two pieces of Rocket Lab hardware: the 57-foot-tall Electron booster, which is currently used to launch small satellites into space, and the Photon satellite bus, which recently made its debut flight. The Photon will launch atop the Electron booster, then it'll make its way to Venus on a flyby trajectory. When the Photon gets close enough, it'll deploy a probe into the atmosphere. Its goal will be to hunt for signs of life in the deck of Venus air that is habitable. But before the mission, everyone will get a chance to see the Electron and Photon in action, as it's booked to take a NASA satellite to the Moon in early 2021. And speaking of NASA going to Venus, they have 4 finalists for the next round of Discovery missions. 2 of these newly announced finalists are targeting Venus. One of these is the Da Vinci Plus mission, which would send a probe down through the thick Venusian atmosphere while gathering data on the way. The second is the Veritas mission, which is set to map Venus's surface in detail from orbit. This probe's observations would help show the planet's geological history and could confirm if volcanism and plate tectonics are active on the planet today. Many planetary researchers say that Venus is truly undervalued, and that we need more missions to study the planet to get a more detailed understanding of its history and its evolution. This could help us understand what happened to the planet, and if our planet is next and will end up like Venus. Since the beginning of the space age, mankind has developed many new technologies to help better study the universe, our galaxy, the solar system, and look for evidence of extraterrestrial life. Look at this tiny pinhole of light in space. That's us. That's planet Earth. On August the 25th, 2012, 35 years after it was launched, Voyager 1 left our solar system. On its way out, it snapped a photo of the Earth from 3.7 billion miles away before turning off its cameras to conserve power. Now it's reached interstellar space, and after 43 years and 4 months, the spacecraft still communicates using the Deep Space Network. But Voyager 1 found that interstellar space is a lot weirder than we thought. What have we discovered, and why is it so important? In the summer of 1964, NASA developed ways to study the outer planets of the solar system in the NASA Jet Propulsion Laboratory. Engineer Gary Flandreau predicted that by the end of the 1970s, there'd be a rare alignment of the planets Jupiter, Saturn, Uranus, and Neptune that only occurs once every 175 years. This alignment of the planets would allow mankind to visit all 4 planets during a single mission. The flight would change its trajectory at each planet and increase the speed of the probe enough to reach the next point in its flight path. Gravity maneuvering, or slingshotting, is when a spacecraft is pulled by a planet's gravity and increasing speed as it shoots around the planet, saving tons of energy and time. As an example, flight to the farthest planet, Neptune, could only take 12 years instead of 30. The Mariner Jupiter-Saturn project began in early 1972 at a cost of $360 million. In March 1977, just a few months before launch, due to the mission's importance, the probes were renamed Voyager 1 and Voyager 2. The Voyagers were equipped with computers that could be reprogrammed, allowing researchers to change programs and fix any problems on the fly. On August the 20th, 1977, Voyager 2 was the first sent into space, 16 days before Voyager 1 would be launched. But because it was on a trajectory that took longer to reach Jupiter and Saturn, Voyager 1 would eventually pass it. Since 1962, there's been interplanetary missions to study Venus, Mars, and Mercury, with missions lasting up to 3 years. But the probes would need to last long enough to be part of the Grand Tour project at NASA, which needed 2 probes to study the 4 gas giants Jupiter, Saturn, Uranus, and Neptune. But it was later suggested that Voyager 1 and 2 visit only 2 planets. Information in the press spread saying that only Jupiter and Saturn would be visited, reducing the overall cost of the project. Experts looked at over 10,000 trajectories before they chose 2 that would allow them to fly by Jupiter's largest moon, Io, and then Saturn and its largest moon, Titan. This route also gave the spacecraft the opportunity to continue towards Uranus and Neptune. The thought of extraterrestrial civilizations intercepting these probes was on the minds of researchers. American astronomer Carl Sagan, along with his team, created a golden record, with 115 images encoded in analog form, spoken human greetings in 55 languages, a variety of natural Earth sounds like wind and thunder, sounds of animals like birds and whales, and different music from around the world.
Hello from the children of planet Earth.
Which probe made the first planetary mission? The original mission plan was for the Voyagers to operate and last only 5 years. It would be long enough for them to study Jupiter, Saturn and its rings, and the 2 planets' largest moons. However, as the mission continued, the ambitions of scientists grew, and the Voyagers outperformed well beyond what was expected. On March the 5th, 1979, Voyager 1 was 173,983 miles away as it approached Jupiter and was able to snap images of its moons Io and Europa. And although Jupiter has been one of the most studied planets in our solar system, new photographs gave researchers unseen angles and more information about these planets as if they were new worlds. The new images of Jupiter's closest moon, Io, had yellow, orange, and brown surface colors, showing scientists evidence of volcanic rock. At least 8 active volcanoes were spotted on Io, shooting material into space, and stunning images of this were captured when Voyager flew by. Io turned out to be the most volcanically active body in the solar system. A little over a year after launch, Voyager 1 approached Saturn on November the 12th, 1980. Expectations were greatly met, and researchers were able to expand their understanding and knowledge of Saturn. 3 new moons were discovered: Prometheus, Pandora, and Atlas. But the biggest accomplishment was getting new information about Saturn's largest moon, Titan. It's the only moon in the solar system that has a thick atmosphere. Similarly, it was discovered that the upper layers of Saturn's atmosphere consists of 7% helium, and the rest is hydrogen. Voyager 1 also discovered Saturn's G-rings, disc-shaped plains made of ice and dust. Another interesting discovery was Saturn's sixth largest moon, Enceladus, which was found to reflect more solar light than any other object in the solar system because of the fresh, clean ice covering its surface. Images were captured that showed its crater-ridden landscape, indicating some geological activity under the surface that could be a source of heat for a liquid ocean. But Voyager 2 was about to make some discoveries of its own. On July 9, 1979, Voyager 2 made its closest approach to Jupiter and snapped this amazing photo of Jupiter and its moon Io, casting a shadow on the gas giant. On August 25, 1981, after successfully arriving at Saturn, the probe snapped images of the gas giant's rings and moons. It was clear at this point that Voyager 2 could now fly to Uranus with all its instruments remaining functional. NASA asked for more money and instructed the NASA Jet Propulsion Laboratory to extend the Voyager 2 mission to Uranus and Neptune. On January 24, 1986, the Voyager 2 probe approached Uranus at a distance of 50,600 miles above the icy cold cloud tops and gathered data that revealed 2 new rings, 11 new moons, and recorded the surface temperature of Uranus at a chilly -353 degrees Fahrenheit. Uranus rotates at an angle, and its magnetic field is displaced from the axis and plane that all other planets are found in. The data also showed that both of Uranus's poles have the same temperature, although only one receives sunlight. Researchers figured the planet must spread temperature in different ways. Recently, researchers were going over the decades-old data and studying the 45-hour convergence of the probe and Uranus when they noticed a 60-second jolt in its magnetic recording. It was discovered that Voyager 2 flew through a plasmoid, a giant magnetic bubble that might have been carrying the atmosphere of Uranus out to space. Actually, all planets leak atmosphere into space, and even Earth's atmosphere does the same thing. But don't worry, we have enough atmosphere to last billions of years. When Voyager 2 approached Neptune, researchers didn't think they'd see anything other than darkness. NASA crews increased the size of Deep Space Station's radio antenna in Canberra, Australia, to catch the incredibly weak radio signals that the probe was relaying from Neptune. On August 25, 1989, Voyager 2 was 30,000 miles away from the 8th planet in the solar system. Approximately 30 times farther from the Sun than the Earth, Neptune receives only 0.01% more sunlight than the Earth. In almost complete darkness, Voyager 2 started taking mysterious photographs. They revealed the makeup of the blue planet, showing the presence of methane, 6 new moons, and 4 rings. Like Saturn and Uranus, the rings and Neptune's 4 moons made a complex, interconnected system. The probe also discovered winds measuring 1,500 miles per hour around a strange, previously unseen place on Neptune named the Great Dark Spot, a massive, rotating storm the size of the planet Earth. In fact, both planets, Uranus and Neptune, are known for strong winds that can reach supersonic speeds 10 to 15 times stronger than on Earth. Uranus and Neptune were originally thought to be gas giants, but in the 90s it was discovered that they were made up of heavier substances, and they became a distinct class of planets called ice giants. Triton was no less impressive. This moon of Neptune is located to the planet's north. It's the coldest of all natural bodies astronomers have discovered at a frosty -391 degrees Fahrenheit. Voyager 2 was able to approach the planet at a distance of about 25,000 miles and discovered active geysers that spewed nitrogen into space. Triton was the final object that the space probe would meet in the solar system before heading out into the great unknown. Where will the Voyagers go next? The Voyager's interplanetary missions have been completed, providing astronomers with lots of new knowledge and a better understanding of our solar system. These 2 probes, together, made huge breakthroughs in astronomy. Distant object in space made by humans, and Voyager 2 was the first to study the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, and also entered interstellar space in November 2018. But when Voyager 1 went into interstellar space, the instrument that measures the temperature of plasma had stopped working, but Voyager 2 still had a working instrument. Our Sun does a lot more than just provide light and warmth. The entire solar system is moving through space and is surrounded by a bubble called the heliosphere. This bubble is continually inflated by plasma coming from the Sun and is known as the solar wind. It extends 11 billion miles from the Sun's leading edge, surrounding all 8 planets and beyond. And a good thing too. Outside the heliosphere, in interstellar space, radiation levels and cosmic rays are a lot higher than inside the bubble. The sun's solar winds are protecting the entire solar system as it flies through space. The heliosphere extends far beyond the region of Pluto until it encounters what is called the termination shock, where its motion slows abruptly because of the outside pressure of the interstellar medium. Voyager 2 discovered that the interstellar medium was at least 54,000 degrees Fahrenheit, but the plasma is so thin and diffuse that the temperatures around Voyager 2 remained extremely cold. The Voyagers have started supplementary missions to study the outer regions of the solar system in interstellar space. These two probes are still speeding across interstellar space and will never return to the solar system and only have the infinite reaches of space ahead of them. NASA's website shows where the Voyagers are in real time. They're getting further and further away from the Earth, every day letting us know we could expect the unexpected. It seems there's no other place in the universe with a dense atmosphere. Mountains, sand dunes, plains, lakes, rivers and oceans, except the planet Earth. But it turns out there's actually a place much like the Earth in our solar system that has a complex weather cycle, landscapes carved by liquid, and volcanic activity. It may even resemble the Earth in its earliest stages, and some scientists think it might be better to colonize it first instead of Mars. This is Saturn's moon, Titan. Recently, something bizarre was found hidden in its orange clouds, and because of this, NASA is now planning a mission to Titan. But what did they find, and why was it so important? Before we get to that, let's learn a little about this strange world that orbits Saturn. Our solar system is home to more than 150 moons, but only 4 of those have an atmosphere. One of those is Titan, the second largest moon in our solar system, and the largest moon of the planet Saturn. Titan is also the only place in the solar system other than the planet Earth that has liquids on its surface. It has a weather cycle much like ours, but has clouds that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining, long-term human settlement. Titan is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as Earth's. The atmospheric pressure is about 60% greater than on Earth. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from the sun, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. Mars doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of the Earth's. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from the sun. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only sunlight that reaches its surface is like late sunsets on Earth. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to Saturn, meaning one side always faces the planet. It's 759,000 miles away from Saturn and has a radius of about 1,600 miles. It takes the Titan 15 days and 22 hours to make a full orbit of Saturn, and 29 Earth years to make a complete orbit around the Sun. No one is certain what Titan looks like under the surface, but on January 14, 2005, the European Space Agency's robotic lander Huygens made a dramatic descent through the Moon's orange, smoggy atmosphere and landed on the surface of the Moon. The camera on Huygens shows a desolate-looking surface and captured the trademark yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan has 5 primary layers of rock. The soggy Moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by a layer of salty liquid, and an outer crust of water ice sits on top of this. The surface is coated with organic molecules that have rained or settled out of the atmosphere in forms of sands and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of life there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for life on Earth are also on Titan, even though the conditions are far harsher than Earth. Some life forms are a lot tougher and stranger than we think. Take, for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's life on Titan, it could be hidden underground, and a lot weirder than we think. The Cassini spacecraft revealed that the Moon is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for life as we know it in the subsurface ocean, or bizarre alien life that we don't know about yet in the hydrocarbon liquid on the surface. NASA was so intrigued by this new discovery on Titan that it wants to study the Moon more and announced the Dragonfly mission in 2019, which is planned to launch in 2027. It'll take 9 years for it to reach Titan, arriving in 2036, and will cost a total of $1 billion, including its ride into space. The Dragonfly is a very unique spacecraft design and is much like a large quadcopter drone with 2 rotors on each of the spacecraft's 4 corners, hence the name Dragonfly. When it arrives at Titan in the year 2035, it'll need to travel to different areas for study. The Mars Curiosity rover used special tracks to roam the red planet, but with Dragonfly, scientists decided to take advantage of the Moon's low gravity with a flying vehicle. This will be the first time that NASA will fly a multi-rotor spacecraft for science, and Dragonfly will be able to make vertical takeoffs and landings. Despite the lower gravity on Titan, it still needs electricity to fly around. So the Dragonfly is equipped with a radioisotope thermoelectric generator, a type of nuclear battery that converts heat from decaying plutonium-238 into electricity. This means it could fly and operate on Titan for decades. Since Dragonfly can easily fly around, it can be moved so that it's always facing the Earth for direct communication, which takes 70 to 90 minutes each way, since Titan is so far away from the Earth. During its proposed 2.7-year mission, Dragonfly will take advantage of the dense atmosphere that'll keep cosmic rays and radiation from destroying it. And it will fly to many different locations to pick up surface materials for chemistry experiments. It'll also check out the planet to see if it's possible for humans to inhabit it one day. Since the building blocks of life, or the organic molecules on Titan, are expected to be similar to those on Earth before life arose, Dragonfly will help study how far pre-life chemistry has progressed to see how life evolved on our own planet. See, we have no idea how life really formed and began on our planet. All we know is that it involved organic molecules. Dragonfly will check out the Moon's atmosphere, what the surface is made of, and the ocean that lays below the surface, looking for complex organic materials that are the keys to life. Now, the only thing left is to build the spacecraft and get it ready to launch. Even if we don't find what we're expecting there, the Dragonfly mission will show us a lot more about Titan. It seems that we may soon find life on another planet or moon, and that'll be a very exciting time for science and humanity. Everyone knows that Jupiter is the largest planet in our solar system. It's 318 times as massive as Earth and 2.5 times bigger than all the other planets combined. It's a gas giant, and for a long time, scientists haven't exactly known what lies beyond the violent swirling clouds in the atmosphere. But now, scientists have discovered what the inside of Jupiter really looks like. What have they found? And has Jupiter really saved the Earth from total annihilation because of its incredible size? Our solar system began as a disk of dust and gas some 4.6 billion years ago. The first planets to form were the gas giants Neptune, Uranus, Saturn, and Jupiter. Jupiter took shape about the same time as the rest of the solar system, forming around 4.5 billion years ago, its strong gravity pulling in massive amounts of gas and dust from the disk before all the other planets formed. It was the first and the largest. Jupiter is mostly made up of hydrogen and helium, about 90% hydrogen and about 10% helium, almost the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant only has a mass of 1/1000th that of the Sun. Jupiter just isn't massive enough for gravity to trigger nuclear fusion. The beautiful whirling clouds and storms that you see in images, the layer resting on the surface known as the troposphere, are about 31 miles thick and are made up of ammonia, ammonium hydrosulfide, and water, which form the distinctive red and white bands. When you look at Jupiter, you probably think that it must have a solid surface. The fact is that Jupiter doesn't have a true surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly right through Jupiter's atmosphere and come out unharmed through the other side. This is because extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. But we've sent spacecraft to orbit and explore the planet. The $1 billion Juno probe, the farthest space probe ever to be powered by solar arrays, was launched towards Jupiter on August 5, 2011, and arrived in orbit around the planet on July 4, 2016. And what we've discovered and learned about Jupiter is incredible. The newest discovery using data collected from the Juno spacecraft found that the colorful stripes of swirling gas and dust you see in Jupiter's atmosphere were found to run 1,800 miles deep and hold so much gas that the mass is about 3 times that of the entire Earth. These belts of wind flow at speeds of 223 miles per hour and disrupt how mass is spread across the planet. It was also discovered that Jupiter's atmosphere is rotating differently, with zones and bands rotating at speeds that are different by up to 328 feet per second. Those bands on different colors you see are actually traveling in opposite directions. Lighter bands move in the direction of Jupiter's rotation, circling the planet faster than it spins, and the dark-colored bands move slower in the opposite direction and take longer to move around the planet. So how does a giant ball of gas floating around in space stay together and form a planet? The Jovian magnetosphere is the cavity created in the solar wind by Jupiter's powerful magnetic field, ballooning 600,000 to 2 million miles, and tapers into a tadpole-shaped tail extending more than 600 miles behind Jupiter. This magnetosphere is the largest and most powerful of any planetary magnetosphere in the solar system. Jupiter's magnetic field is generated by electrical currents in the planet's outer core, which is composed of liquid metallic hydrogen. This magnetic field was found to be almost 20,000 times as powerful as Earth, and rotates, with the planet sweeping up particles that have an electric charge. The electromagnetic storms they generate are so strong that they can be heard by amateur radio operators on Earth, beamed towards us by plasmas and magnetic field lines. These signals are sometimes even more powerful than radio signals from the Sun. This magnetic field traps swarms of charged particles and accelerates them to very high energies, and creates intense radiation that bombards the innermost of its 67 confirmed and named moons, and would destroy anything that got close. Speaking of Jupiter's moons, scientists have recently discovered an FM signal emanating from one of Jupiter's moons, Ganymede. If you want to see a video about this mysterious signal and Jupiter's giant moons, let us know in the comments. By now you may be wondering, does Jupiter have a solid inner core? Studies have found the planet's interior moves as a single body and behaves as if it were a rigid solid, despite its fluid nature. For now, we simply do not know if Jupiter has a solid core or not, but the Juno spacecraft should be able to help discover this, and what the mass and makeup of this solid core is, if it exists. We do know that at Jupiter's core, whatever it's made of, the pressure is about 100,000 times the pressure on Earth. The Great Red Spot is one of the most iconic features of the planet. It's a massive storm the size of the Earth that's been raging since it was first sighted in 1831. Trapped between 2 jet streams, it's called an anticyclone that swirls about a center of high atmosphere pressure and rotates in the opposite direction that hurricanes do on Earth. It's the largest storm in the solar system, with wind measured around 400 miles per hour. Compare that to the fastest wind speed ever recorded on Earth of 231 miles per hour. One day this great red spot could end up disappearing completely, and scientists say that it's been shrinking since the 1800s, and may only last another 20 years. NASA's Juno spacecraft was able to snap incredible images of the planet as it passed at 5,600 miles above the giant red spot clouds in July 2017. One of the amazing things that was discovered is that deep in the atmosphere, pressure and temperature increase greatly and compress the hydrogen gas into a liquid. This gives Jupiter the largest ocean in the solar system, which is made of hydrogen instead of water. Juno also grabbed some spectacular images of the gas giant's poles, discovering another incredible wonder of the planet. At the North Pole of Jupiter, a huge persistent cyclone is visible and encircled by smaller cyclones ranging in size from 2,500 to 2,900 miles. On Jupiter's South Pole, the same thing was discovered as Juno did a flyby, and using infrared cameras imaged a cyclone the size of the entire USA, with 5 other cyclones swirling around it in a geometric pattern, which also rotate counterclockwise. The NASA Galileo spacecraft was likely the first to discover these hotspots when it accidentally flew through one on its way to a planned demise to the surface of Jupiter. When the spacecraft was almost out of fuel, NASA deliberately sent the craft on a no-return plunge into Jupiter on September 21, 2003. This was done to protect the moon Europa, which some say has a subsurface ocean that could contain life. It's worth mentioning that we probably should be thankful for the planet Jupiter's size and the powerful magnetic field that it generates, because it's possible that Jupiter has saved the planet Earth from certain doom. People were laughing at the prospect of an asteroid or comet hitting the Earth in the late 80s and early 1990s, but then something happened that would quiet that laughter. The comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Levy on March 18, 1993, using the Schmidt telescope at Mount Palomar. Scientists calculated the comet was originally 1 to 1.2 miles wide. However, tidal forces from Jupiter's powerful gravity had broken the comet into more than 20 pieces as it made its close approach to the planet sometime in 1992. But the biggest revelation was scientists saw that the fragments were going to smash into Jupiter, and luckily for NASA, its Galileo orbiter was still on its way to the gas giant. Many Earth-based telescopes and orbiting spacecraft such as the Hubble telescope all were focused on the incredible event that was about to happen. The fragments of the comet were lined up like a freight train and collided with Jupiter's atmosphere, unleashing the force of 300 million atomic bombs. The fragments created huge dark spots in the clouds that measured 1,200 to 1,900 miles and heated the gas giant's atmosphere to temperatures as hot as 53,000 to 71,000 degrees Fahrenheit. If a comet of this magnitude hit the planet Earth, the results would be devastating, with impacts sending dust and debris into the sky, which would cool the atmosphere and absorb sunlight, and envelop the entire planet in darkness. This historic Jupiter comet impact is what led to planetary defense. But fear not, this type of collision was very rare, and scientists say probably only occur every few centuries. Or do they? On August the 7th, an amateur astronomer was looking at Jupiter through his telescope when he captured an asteroid colliding with the atmosphere of Jupiter, creating a white flash visible in the clouds. Some scientists say these impacts are inevitable, with the amount of objects floating around in space, and Jupiter's massive gravity tugging on anything that gets close to it. We could say that Jupiter's like Earth's big brother, and likely protecting us from asteroid impacts. We've learned some new things about Jupiter and how its layers of atmosphere are made up. And we've also been able to image the planet in striking detail. Piecing together images captured at the perfect moment for clarity called lucky imaging, the highest resolution image of Jupiter ever seen has been created in thermal infrared light. In the photos you can see the familiar banding. Bright regions are clear air, where heat from inside the planet can leak out, and darker regions are where the thick clouds block the heat from escaping. This proves that the interior of Jupiter is very hot, heat left over from its formation billions of years ago. When taking a look at Jupiter through the Hubble telescope, what you see is sunlight reflecting off the cloud tops. With these amazing images, we're learning more and more about Jupiter every day. And we're not done yet. Juno is still on its mission, and only about 1/3 through its planned mapping of the planet. And there are still reasons to believe that Jupiter may have a rocky center that's enveloped in a layer of metallic hydrogen. We're definitely going to get more incredible images of Jupiter coming soon, and we're about to unlock the mysteries of the biggest planet in the solar system. So make sure to stay tuned here to see the latest stunning images of Jupiter. Before modern telescopes, humans could only imagine what the surface of the Sun and the planets looked like. Now, advanced technology has made it possible to get in close and take images of the Sun and the planets deep in our solar system. Now, get ready to see the solar system as you've never seen it before, and see images that were so good they shocked astronomers. Burning with the energy of 1 trillion nuclear bombs per second, the Sun is the largest body in our solar system, accounting for 99.86% of the total mass. One of the most dramatic images of the Sun was captured by the Solar Dynamics Observatory on August 31st, 2012, when a long filament of solar material that had been hovering in the Sun's atmosphere erupted into outer space. This beautiful but deadly coronal mass ejection, CME, traveled at over 900 miles per second. The planet closest to the Sun, orbiting at an average distance of 36 million miles, Mercury, has been studied by many spacecraft throughout the years. But NASA's MESSENGER spacecraft was the first to orbit the planet. Images showed the surface covered in craters in all sizes and massive asteroid impact sites like the Van Eyck crater, which is 168 miles in diameter, and the Caloris Basin, which is 960 miles in diameter, with mountains at the outer rim 1.2 miles high. These are images with spectral surface measurements that were taken on April 29, 2015. MESSENGER snapped more than 200,000 images of Mercury before ending its mission in 2015 with an intentional crash into the planet's surface. The probe's demise was inevitable, as MESSENGER had been orbiting Mercury since March 2011 and had run out of fuel. Right before impact, it sent back its final image, the highest resolution photo of Mercury ever captured. You'd think that Mercury would be the hottest planet because it's the closest to the Sun, but our next planet is actually the hottest in the solar system. The second planet from the Sun, and also Earth's closest neighboring planet, Venus, has a thick atmosphere made up mostly of carbon dioxide, sulfur dioxide, and nitrogen gas, which traps the heat of the Sun, making it a hellish world. Venera 13 was a probe built in the Soviet Union for the Venera program to explore Venus. It was the first lander to transmit color images from the surface of Venus. Venus is a hot world, with surface temperatures as high as 880 degrees Fahrenheit. The probe was designed to only last 30 minutes, but it must have been built like a tank, because it continued to transmit data and images for more than 2 hours after landing on March 1st, 1982. NASA then sent the Magellan spacecraft to Venus in 1990 to image and map the entire surface. It sent back images of the planet's surface showing evidence of volcanism, tectonic plate movement, turbulent surface winds, and miles of lava channels, including one measuring 5,550 miles long. Another incredible image of the volcano Mat Mons that rises 3 miles. Once Magellan was finished mapping the entire surface, it also ended its mission and crashed into the fiery planet. The third rock from the Sun, the Earth, is very unique, and the only place known to have life in the solar system. There have been lots of amazing images taken of the planet we live on, but modern satellite photos are probably the most breathtaking, like this image from NASA of the Earth as it looks right now. This amazing true color image was taken by NASA's Moderate Resolution Imaging Spectroradiometer from 22,000 miles above the Earth, and shows North and South America as they appear from orbit. The Moon also making a guest appearance in the background. And on December 14th, 2020, NASA captured a total solar eclipse with the GOES 16. That's quite amazing. But here is something you may not have seen. In March 2011, a Russian satellite named Elektro-L captured incredibly detailed images of the Earth that appear to rival NASA images. Many claimed that they are more accurate and show different things, but NASA say they're not accurate. We're not sure. But which images do you think are the best? And by the way, remember the Messenger spacecraft? It snapped a photo of the Earth and of the Moon and sent us a postcard before speeding towards Mercury. Mars has always been of great interest to humans. The fourth planet from the Sun, the red Martian planet, has been studied heavily. The Viking Orbiter 1 took stunning snapshots of Mars in 1979, like this photo of the Valles Marineris. And the Viking 2 orbiter snapped an image showing the southern polar plains and polar ice cap. In 2013, the Mars European Space Agency's Mars Express took highly detailed images of Hebes Chasma, the northernmost part of Valles Marineris, as seen in this movie created from the images. But since then, 4 rovers have already been on the planet's surface studying and snapping photos. The images from the Mars Curiosity rover, including a selfie, were the most incredible images from the surface of an alien world. This is a 1.8 billion panoramic view made up of over 1,200 images of Mars as seen by Curiosity, which is still operational. The largest planet in our solar system, the gas giant Jupiter, has the most unique look of all the planets with its giant Great Red Spot, a storm on the planet that's been raging for 350 years and is so large it could swallow the Earth whole. On July 10, 2017, the Juno spacecraft flew just 5,600 miles above the Great Red Spot and nabbed the closest image of the massive storm ever taken. This image, a bit farther away, is a little bit truer in color to what we would see if we were orbiting Jupiter. But Juno also captured unbelievable images of polar regions, which cannot be seen from Earth. And what surprised astronomers was that Jupiter's North Pole has 8 storms swirling at its center, and they're laid out in a precise geometric pattern, the storms appearing as stable fixtures in Jupiter's atmosphere and not normal weather. But more incredible photos would come, and on November 13, 2018, a new image from Juno was created using data from the JunoCam imager that's nothing short of breathtaking. And on June 27, 2019, the Hubble telescope captured the planet's trademark Great Red Spot, which researchers say is shrinking. We got an awesome video coming up on Jupiter, so make sure not to miss it. As the #1 contender for the most beautiful celestial body in the solar system, Saturn is hard to beat with its iconic rings. And probably the best images of Saturn to date come from the Cassini-Huygens spacecraft. On October 21, 2002, the spacecraft was 177 million miles away from Saturn when it snapped this photo. And on March 27, 2004, as it got closer, took this natural color image as it neared its arrival into Saturn's orbit. Now here's a mind-blowing image of Saturn you may never have seen before. This is Saturn backlit by the sun, and with that added light, Cassini was able to image the ring system in a way not possible from Earth, and the result is stunning. But in 2004, the Hubble telescope was also in on the action and snapped an amazing photo of an aura. In 2016, the Cassini spacecraft sent back images of Saturn's northern hemisphere. What scientists were surprised to see was a hexagonal vortex storms. They've been studied, but no one's sure how this forms. On September 15, 2017, the spacecraft made its final approach towards the gas giant, and before sending this final image, burned up in Saturn's atmosphere like a meteor. Known as the Sideways Planet because it rotates on its side, the 7th planet from the Sun. One of the best images taken, Voyager 2, made a flyby of the planet in 1999, and this image was taken using 3 color filters. And on July the 11th and 12th, 2004, a composite image of Uranus obtained by the Keck telescope was published showing the icy cold world and its rings. Those bright spots that you see on the surface of the planet are auras. In November of 2011, the Hubble telescope snapped an awesome image of Uranus, and a colorized photo shows an icy blue sphere with red rings. And in 2017, the Hubble telescope captured auras again on Uranus. Neptune is the 8th planet in our solar system and the farthest away from the Sun. The only spacecraft that's been close to Neptune is Voyager 2. One image taken by the spacecraft shows a giant storm raging on the surface of the planet, Neptune's Great Dark Spot. Before Voyager 2 would complete its mission and head towards interstellar space, it made a close approach and snapped this image showing bright cloud streaks in Neptune's atmosphere. The Hubble telescope has taken a recent image of Neptune and in December 2020 snapped this image with the Great Dark Spot. Because it's so far away from us, the best images we have of Neptune from Earth so far was taken by the European Southern Observatory's Very Large Telescope, using a special narrow-field adaptive optics mode of the multi-unit Spectroscopic Explorer instrument. Many argue whether Pluto is a planet or not, but you're here to see some photos. One of the clearest images of Pluto that you'll ever see was taken by the Long Range Reconnaissance Imager, which is aboard NASA's New Horizons spacecraft on July 13, 2015. But it wasn't done yet, and on the next day, this image was put together by combining blue, red, and infrared images taken by the spacecraft. The New Horizons spacecraft continued to take crystal clear images of the planet. Pluto also has a moon called Charon, as seen in this composite of enhanced color images. And this image is the most striking, showing mountains across an icy plain. Humanity has achieved great results getting new images from planets in our solar system and making incredible discoveries. We're still too far away to get close images of Proxima Centauri, the next planetary system to ours, and current spacecraft headed in that direction will take thousands of years to get there. But there are plans to create a wafer-thin nanoprobe called Breakthrough Starshot that has thin sails to capture energy from a powerful Earth-based laser. This would accelerate the probe at 134 million miles per hour, meaning the tiny probes could reach Proxima Centauri in 20 to 25 years. Just think of the images it could take. If that happens sometime soon, you'll see it here.
Everything grows, but the 3D is really...
Today's solar scientists believe it's not if, but when the next big one will strike. With the next solar maximum due in 2013, it begs an all-important question. Can we predict when the next solar storm will hit?
No.
Maybe.
No.
Maybe.
No.
Maybe. And the reason why is we've learned so much about the sun. We're getting better at it, but we have a long way to go. And the more we look at some of these historic events, the more we get a deeper appreciation for what we need to know.
Today, we see the sun better than ever before. We're beginning to understand it from the inside out. But its unpredictable personality means there will always be uncertainty when living with a star.
The sun, our nearest star. In the fall of 2003, it unleashed an eruption of energy equal to 200 billion hydrogen bombs. Blasting a tidal wave of superheated charged particles at speeds of up to 6 million miles an hour. It was one of the largest solar storms ever recorded. And it was aimed at Earth.
They were some of the fastest, hottest, and strongest storms ever measured.
Assaulting the Earth, the sun's energy forced space station astronauts to take cover in their most sheltered compartments. Lights went out. Communication streams were cut. Airliners scrambled for safety.
This really was a hurricane of space storms.
Though no major damage was done, these storms were a stark reminder that we live at the constant mercy of the sun. It controls all aspects of our lives. Our climate, our food, our bodies.
We actually live inside the sun's atmosphere. We, along with all the other planets, are greatly influenced.
But is its influence changing?
It's actually growing more powerful.
Might we lose its protection from deadly cosmic rays?
At its boundary, where it's protecting us from the intergalactic winds, that boundary is actually shrinking a bit.
Will our technology-dependent society be able to handle another solar superstorm?
Sometimes these effects can be so severe that they're catastrophic.
And when will the next superstorm strike?
Three, 2, 1, go for drop.
Pegasus is away on the IBEX mission.
Fall 2008.
Stage 1 ignition.
NASA launches IBEX, the Interstellar Boundary Explorer. Part of its mission is to study the effects the sun has on the furthest reaches of our solar system. IBEX joins the long list of human attempts to explain our star's impact on our solar system, our planet, and our lives.
The sun. The sun provides all of our light and heat. If it weren't for the sun, we wouldn't be alive.
We people are very interested in what goes around us. We like to understand our neighborhood. The sun in the universe is our street, our neighborhood.
The sun. We are actually affected by its moods. In fact, it's like the parent, and all the planets are the children that are affected by its moods.
We need to know how it's going to evolve and how the changes that are always happening in the sun affect us here on Earth.
The sun. If we want to understand the universe and the stars that make up the universe, then it's important to study the one that's closest to us.
We've learned more about the sun in the past 40 or 50 years than in all of recorded history.
This golden age of exploration was kicked off by a unique mission that gave us close-up images of our sun from above our atmosphere.
Skylab, we're reading you loud and clear over the Vanguard for 8 minutes.
In 1973, Skylab became the first manned space station. It sent back images of the sun, clearer than anything taken from Earth.
The Skylab mission was one of the very first laboratories that was dedicated just for the research and study of the sun. In some ways, it's kind of the grandfather of the current missions today.
Right now, a fleet of about 20 space probes scan and study the sun in ways we never imagined, even 30 years ago. By studying the sun from the vantage of space, we can see it in a whole new light. Using different light wavelengths, including X-ray and extreme ultraviolet, we can peel back its layers and begin to understand how and why the sun acts the way it does.
The different wavelengths mean different temperatures, and different structures are more visible in different wavelengths than in others.
Our robotic space probes never stop watching the sun. With their help, scientists are working out the big questions about our star, and we already know a lot. The sun is one of over 200 billion stars in our Milky Way galaxy, but it is our closest at 93 million miles away from Earth, almost the same distance as 4,000 trips around the globe. And despite that distance, its light only takes 8 minutes to reach Earth. It is only 4.5 billion years into its nearly 10 to 11 billion year lifespan. And though technically a medium-sized star called a dwarf, it is enormous, 900,000 miles across, and if hollowed out, 1.3 million Earth-sized planets could fit inside. The sun accounts for 99.8% of the mass in the solar system, and it weighs 300,000 times more than the Earth. It is made up almost entirely of a superheated form of electrified and magnetized gas called plasma. The sun packs enough gravitational pull to keep the planets from spinning off into space. And as Copernicus first suggested, it rules the center of our solar system with a gravitational iron fist.
Copernicus's model, in which he placed the sun in the middle of the solar system with all the planets going around it, instead of everything going around the Earth, was a giant paradigm shift. It meant that the sun is the most important thing in the solar system. It meant that we really should understand the sun.
Our sun, like all other stars in the universe, is made from the dust of stars that lived and died over billions of years, going all the way back to the Big Bang.
So our sun and our solar system is really the debris from many generations of stars.
The sun we see every day is the solar system's source of power. Deep in the center of our star, its core is superheated to 27 million degrees Fahrenheit and is the engine that drives it all.
Inside the sun's core, the process of fusion is occurring, and that fusion process is giving off light and particles.
Every second the sun shines, it releases the same amount of energy as 1 million H-bombs. The sun's light is made of particles called photons, born in the core, then propelled by convection currents through the radiative and convective zones of the sun. Eventually, they reach the volatile outer layers of our nearest star.
The sun's outer parts consist of 3 regions. There's the photosphere, or surface of the sun, and it's not really a hard surface like that of the Earth. The sun is gaseous throughout. And the temperature of the photosphere is around 10,000 degrees Fahrenheit.
Above the thin layer of the photosphere is another thin layer called the chromosphere. And the chromosphere is slightly hotter than the photosphere, which is counterintuitive because you would think that as you go away from the source of all the energy and heat, the core, that temperature would drop. But in fact, the temperature rises from the photosphere to the chromosphere. And it gets even hotter as you rise to the third layer of the atmosphere called the corona.
And then beyond the chromosphere is a large, tenuous, extended region, the corona, which is millions of degrees.
The sun produces a continuous outward flow of energy called the solar wind. Constantly blowing, it carries energy out into the solar system, extending our sun's reach 9.3 trillion miles, well beyond Pluto.
The space in between the planets and the space in the entire solar system is not an empty void, but it's full of these particles and it's full of these rays of light.
While the solar wind blows away from the sun, its gravity holds and pulls everything in. Take comets. All comets orbit the sun and can get pulled directly into the line of fire. Recently, scientists witnessed one of the sun's most dramatic outbursts, a coronal mass ejection, ripping the tail off a comet.
When it hit the comet, the tail was cut off like you took a knife, and the tail drifted away. And then it took a little more time for the comet to generate more gas and plasma and dust and create a tail. It tells us about how the solar wind moves in the solar system and how it can affect things.
The sun affects everything it touches, even us. To learn just how much, scientists sometimes rely on a remarkable cosmic coincidence. The lethal output of the sun has made studying it almost as difficult as understanding it. But scientists can get a good look at our nearest star thanks to a cosmic coincidence. A total eclipse of the sun.
A total solar eclipse occurs when, from our perspective, the moon is exactly aligned with the sun and blocks its photosphere. It's a glorious sight.
The solar eclipse is the most wonderful thing to see. It grows really dark by factors of thousands within seconds. And as it does become so dark, you can look up in the sky, you see the dark shadow coming from one direction, sweeping at you. It's really coming at thousands of miles an hour. So it's very impressive to see.
Humankind has marveled at the mysteries of the eclipse for millennia. Scientists have used it as an opportunity to see the sun's outer atmosphere, the enigmatic corona. One of the hottest regions of the sun, energy from the corona radiates out to the edge of the solar system.
The entire solar system actually sits in this outer corona of the sun. So this atmosphere of the sun is bathing all the planets.
The engineers who built the Solar and Heliospheric Observatory, or SOHO, installed an artificial eclipse into the space probe. Called a coronagraph, it does the same thing as a natural eclipse, blocking out the blinding rays of the sun, so scientists can try and answer an old question.
How does the solar corona get so hot? After all, the everyday surface of the sun, the photosphere, is only around 10,000 or a little more Fahrenheit. And the corona, on the other hand, is millions of degrees hot. If you go away from a stove, you know it gets cooler, but if you go away from the everyday surface of the sun, it gets hotter. And how is that?
It all starts at the sun's core, where every second, nearly 700 million tons of the universe's most common element, hydrogen, are converted into helium through nuclear fusion, giving off the energy that becomes photons, otherwise known as light.
The sun's core is really hot, several tens of millions of degrees. And there the temperatures are so high that protons, hydrogen nuclei, can come together, grab each other, fuse, eventually into helium, and in this way release energy.
What happens with these photons, they go through this process, what we call a random walk, where they have to go through the layer of the sun, they get absorbed and then reabsorbed into lots of different photons at lower energy level. So this process of being absorbed and reabsorbed millions of times can take 150,000 years.
Once out of the sun's interior, photons are only 8 minutes away from Earth, but they're leaving behind a world in constant motion. The solar surface boils. Energy rises constantly from below. Coils of plasma and energy called coronal loops spring across the sun, while dark regions known as sunspots stretch thousands of miles. And at only 7,000 degrees Fahrenheit, these sunspots are the coolest part of the sun, emitting less light than the surrounding area.
If you were to pluck a sunspot away from the sun and place it in the sky, it would actually be as bright as the full moon.
Sunspots appear on the surface and are easy to see. Their genesis, however, is tied to the sun's deep interior and complex rotation.
The sun doesn't rotate like a solid body. Instead, it rotates more quickly near the equator than near the poles, which leads to sunspots. The equator completes one rotation in 25 days. Mid-latitudes complete one rotation in about 30 days, and near the poles, one rotation is completed in about 35 days.
Called differential rotation, this process makes the sun's interior churn at different speeds, creating intense magnetism in the form of millions of magnetic field lines, which get mixed up as the sun's interior twists up like a rubber band.
This builds up pressure, which makes them buoyant. So they float to the surface, and where they pop through the surface, they create sunspots.
Once on the surface, the now twisted and balled up magnetic field lines block the convection of superhot plasma from rising, making sunspots appear dark.
And when those sunspots start to twist around, you can imagine that you have one sunspot here and one sunspot here, and there's a magnetic field that connects the two. And that magnetic field gets twisted, and eventually the same sort of thing that happens with a rubber band, it pops. And when the magnetic field pops, it releases energy. And in the case of the sun and solar flares, it releases huge, huge amounts of energy.
The magnetic field lines created by the twisting and churning of sunspots, though invisible, can be seen in the dramatic formations on the surface of the sun, in the form of flares and prominences. It is here that the sun's influence starts, as the breaking of these magnetic field lines drives massive amounts of energy from our nearest star out into the solar system. And it is these magnetic field lines that are behind most theories on why the corona is so much hotter than the surface.
It's pretty clear that it has something to do with the magnetic field that heats the corona. But presumably there are waves along the magnetic field that bring energy from underneath the surface of the sun into the corona.
The solar probe Hinode, which means sunrise in Japanese, was launched in 2006. Its mission to study the interaction between magnetic field lines and the corona. Recently, it captured images of one of the waves thought responsible for heating this enigmatic region, Alfvén waves.
Alfvén waves are waves that occur in a plasma, in a bunch of ionized gas, threaded by a magnetic field. And indeed, it's thought that these Alfvén waves might be bringing turbulent energy from inside the sun out to the corona, where that energy heats the corona.
Energetic Alfvén waves form inside the sun and travel up through the surface, making the looping magnetic field lines sway and vibrate.
And so through this vibration or this oscillation, they're having friction with the magnetized plasma surrounding it in the corona. And through this friction, heating occurs.
It's this heat delivered to the corona that radiates out into space, filling our solar system with the sun's energy. But this energy is not constant. Our sun is an ephemeral body, never the same from one day or 1 year to the next. Like Earth changes with seasons, so does the sun. And when the solar seasons change, anything can happen. Day in and day out, the sun we see appears the same. But like Earth, the sun has seasons, solar minimum and solar maximum. Two distinct personalities that can affect our technology and possibly even our weather. The transition between solar minimums is called the solar cycle, an average 11-year period in which the sun's activity maxes out, then ebbs again.
The primary measure of the solar activity cycle is the number of sunspots visible on the sun.
During solar minimum, the period with the fewest sunspots, solar activity is limited. When sunspots break through the surface during solar max, the sun's power reaches out.
When there are lots of sunspots, there are lots of flares and coronal mass ejections.
Increases in solar activity enhance the connection between sun and Earth. Energy expelled from the sun can create disturbances in the near-Earth environment.
The Earth is embedded in the solar atmosphere, and so what happens on the sun affects the Earth. And that's what we call space weather.
Accurate space weather forecasting is the ultimate goal, but this can be hard. The sun is turbulent, especially during solar maximum, the peak of solar storm activity.
During solar maximum, the magnetic field of the corona becomes very complicated, and you have magnetic field everywhere, all around, even near the poles. You can have coronal mass ejections and flares and solar storms occurring sometimes several times a day.
Solar flares, violent eruptions of energy, usually near sunspots, burst into space. Like a bolt of lightning, quick and powerful, they can happen over a matter of minutes and can give off the same amount of energy as 1 billion megatons of dynamite.
Solar flares are gigantic outbursts of energy from the sun, coming from a very small localized region of the sun's surface. So they're very concentrated ejections of energy that heat the surrounding gas to 10 million degrees.
Solar flare is sort of like a snapping of the whip. It really releases a lot of energy very quickly, accelerating particles almost up to the speed of light.
The particles from the very most energetic solar flares can reach us in something like 15 minutes.
But the solar hurricane of space weather comes from coronal mass ejections. These massive blasts carry billions of tons of superheated gas and plasma into interstellar space.
So coronal mass ejection is where a huge amount of mass and energy is expelled away from the solar surface. So if you can imagine this huge amount of mass and energy traveling away from the sun at these large speeds, sometimes at over 1 million miles an hour.
They throw these like big bubbles of hot gas and magnetic field. It can move off the sun so quickly that it actually creates a shock wave. They're the biggest storms, and they're the important ones for understanding space weather.
Solar probes, like SOHO, have captured the sun expelling massive amounts of energy into space. But scientists are most concerned when they see something called the halo effect, when the cloud of energy appears to surround the coronagraph. That means the sun has aimed its latest blast at us, like in the massive solar storms of 2003.
The fastest coronal mass ejection ever studied in modern times came from these storms.
Shortly after the initial blast from the sun, SOHO was bombarded by charged solar particles, protons and electrons, overwhelming the camera and causing the image to drop out.
What happens is you see a sort of snow on the camera, all sorts of sparkles going by, and that's the particles accelerated by the coronal mass ejection hitting the actual camera on SOHO.
If caught off guard, solar storms can harm astronauts, exposing them to the same amount of radiation in seconds that we receive on Earth in a year.
So if we're going to send astronauts back to the moon and to Mars, it becomes very important to be able to determine when these coronal mass ejections and storms are going to occur. The charged particles embedded in these coronal mass ejections are dangerous. It's a lot of radiation that would hit an astronaut.
Astronauts and satellites aren't the only potential victims of solar storms. The particles blasted towards Earth can interact with our magnetic field, occasionally wreaking havoc.
When this material comes smashing into the Earth's magnetic field, it causes it to ring almost like a bell. And when you have a magnetic field, and when that magnetic field moves, physics tells us it's going to create currents. And so electrical currents will be created in the outer atmosphere of the Earth. And these electrical currents can cause all sorts of disturbances.
The currents create problems for satellites orbiting the Earth. They disrupt global positioning systems. They can interfere with communications equipment, causing radio blackouts and knocking out mobile phone systems.
These mass ejections can send so many charged particles toward the Earth that some of them make it through the Earth's magnetic field and even reach power stations here on Earth, causing surges of electrons and power outages and short circuits and things like that.
In extreme situations, solar storms cause excessive radio interference and increased levels of radiation, requiring planes flying near the poles to be rerouted. But as powerful as the storms were in 2003, they're no match for what astronomer Richard Carrington saw in 1859, a super flare.
The super flare of 1859 was incredible because prior to this event, we didn't even know that flares existed. Carrington saw this huge bright flash on the sun with the unaided eye. And in order for him to see that, it had to have been a super huge flare.
There were reports of telegraph lines running without being powered.
We probably won't see another one that intense in our lifetime, although it's hard to say for sure. The sun has thrown us some surprises.
If a similar storm were to strike today, one recent estimate projects 130 million people would lose power, possibly for months.
Most of the electrical infrastructure, the power grids around the world, would be knocked out. A lot of the transformers would be overloaded. Having a large portion of the population with no power for many, many months could cost huge amounts of money. People have estimated that it would be upwards of $2 trillion.
We won't know unless it actually happens, and the more warning we get, the more we can do to reduce the economic impact, which is one of the reasons why we're studying the sun.
Scientists are a step closer to being able to predict these storms since the launch of the Solar Terrestrial Relations Observatory, also known as STEREO. This pair of probes now gives scientists the ability to see the sun in 3D.
So now, when one of these coronal mass ejections travels towards us, we're actually looking at the side view. And so we can see how fast they're traveling, we can see how they're evolving, the structure.
In 2011, the STEREO probes will reach their ideal vantage point, opposite sides of the sun, giving NASA a 360-degree view, allowing them to see what is coming from the far side of the sun before it impacts Earth.
And so for the first time, we're going to have a complete view of the sun all the way around. So this is going to allow us to see everything that's happening on the sun at the same time, and this will lead us again into a better ability to predict these types of storms.
But as dangerous as solar maximum can be for its increase in space weather, the sun's solar cycle counterpart and calmer period, solar minimum, may come with its own dangers.
When there are a low number of sunspots on the sun, the climate here on Earth can actually cool a little bit.
2008 saw the fewest number of sunspots in nearly a century, with a total of 266 sunspot-free days.
In 2008, we were at sunspot minimum, but by now we expected to be climbing out of that sunspot minimum, and we're not. So this could mean that this particular sunspot minimum is more protracted.
Scientists believe that past protracted minimums have had a chilling impact here on Earth.
Now, every once in a while, the sunspot activity cycle seems to just go away or become much diminished. There was such a period around 1650 to the early 1700s.
There were only about 50 sunspots recorded, when normally in the same time frame there are tens of thousands. So it was a really low period of sunspots.
It was called the Maunder minimum. The sun was in a quiet state. And that was associated with lower than normal temperatures here on Earth. Europe experienced sort of a mini ice age during those few decades.
Whether or not this current minimum will be protracted enough to have such a large impact on Earth won't be known for years. But another measure of solar activity, the solar wind, appears to be waning. And that could impact Earth tomorrow. Bathed in the sun's atmosphere, Earth is shielded from deadly cosmic rays. And while the sun's power protects us, it can also harm us. Life on Earth survives this close to its star, thanks in part to its ozone layer. But what would happen if the ozone layer were gone?
If Earth lost much of its ozone layer, ultraviolet radiation from the sun would penetrate through the atmosphere and reach the Earth's surface.
The sun's massive amounts of ultraviolet rays would quickly eliminate most basic elements of the food chain, wiping out plants and then animals.
If we are bathed in huge amounts of ultraviolet light, eventually the life on the Earth would die.
But what could cause such a catastrophic collapse of the ozone layer? Something the sun is supposed to protect us from: a gamma ray burst.
Gamma ray bursts are intense, brief flashes of the most energetic kind of radiation known, gamma rays.
The most powerful events in the universe. In seconds, they give off the same amount of energy that the sun will emit in its entire life. They occur when certain large mass stars die or even collide.
They can be generated from very extreme processes, such as large mass stars collapsing into black holes.
They occur somewhere in the sky, roughly once per day, and they come from very, very far away. Most of them are billions of light years away.
But just 8,000 light years away, deep within the Sagittarius constellation, buried in a pinwheel-like formation, looms a potentially ticking time bomb, WR-104. Two stars locked in a cosmic dance, spinning a full rotation once every 8 months. But one of these stars is on the verge of going supernova and emitting a gamma-ray burst.
Now, one of these two stars is a very massive star that might someday form a gamma-ray burst, and its beam might hit the Earth. If the high-energy beam from a gamma-ray burst were pointing directly at the Earth, it could spell real danger.
The radiation from the gamma-ray burst would be so intense, very short, on the order of 10, 20 seconds, but this would set up a chain of events which eventually would deplete the Earth of maybe 50 or more % of the ozone layer.
Scientists have speculated that a nearby gamma-ray burst caused an ancient extinction on Earth millions of years ago.
At the time, there was only sea life that existed. And even though the sea life deep beneath the sea wouldn't be directly affected by the UV radiation, the plankton and the life near the surface would die off, and therefore the food chain would be affected.
The threat is heightened even further by something scientists have witnessed over the past few decades: a 20% decrease in the power of the sun's solar winds.
The solar wind is the steady emission of particles from the sun.
They carry the magnetic field that is in the solar corona out into space.
It exists even when there are no coronal mass ejections or solar flares.
The solar wind continues way out beyond the orbit of Pluto and has actually blown a bubble in interstellar space.
Now, that's a bit of a protective bubble because the magnetic fields protect us from charged particles coming from outside.
Normally, solar winds stream off the sun in all directions at speeds of 1 million miles per hour. Pulling the sun's invisible magnetic field along with it, they form the solar system's defense against intergalactic intrusion, the heliosphere.
The heliosphere is the very boundary where the solar wind hits intergalactic space. So it's this shell that's surrounding the sun and the solar system where it protects us from intergalactic winds here on Earth.
Recently, scientists have learned that the heliosphere is shrinking and getting weaker.
The solar wind pressure has been measured to be decreasing over the last 25 years. In fact, the heliosphere, where the solar wind pressure is extending out to, has actually shrunk a bit.
A weaker heliosphere increases the possibility that Earth will be exposed to harm from intergalactic cosmic materials.
So if there's less solar wind, then the heliosphere itself is going to shrink. And that makes it easier for more cosmic rays to enter into the solar system.
Already, the amount of high-energy electrons, a small but telling aspect of cosmic rays around Earth, has jumped in number by 20%.
Looks like the cosmic ray electrons have increased, and you would expect that. If the solar wind has decreased by 20, 30% over the last 15 years, the bubble will have gotten smaller, and you expect an increase in galactic cosmic rays.
The good thing for us is that we live on a planet with a thick atmosphere and a magnetic field. So we have two types of shields that protect us.
But that could change when WR-104 emits its gamma-ray burst, possibly upsetting the balance of Sun and Earth, a balance that may already be in jeopardy because of something the Sun did billions of years ago. Over billions of years, the Sun and the Earth have developed the perfect balance for life to thrive. Sitting in the Goldilocks position of the solar system, not too hot and not too cold, the Sun gives us just enough light, just enough heat, and just enough energy to fuel our planet and our lives.
The sun drives everything on the Earth. The sun is the energy source of the Earth. So all of the energy that's given off by the sun heats up the Earth. This drives weather. On a larger time scale, this drives climate. So basically the sun is the energy source. It's the battery that drives the whole Earth environment.
Plants harness the sun's energy through photosynthesis, creating carbohydrates. People and animals consume these carbohydrates, converting them into energy we can use. Even the fossil fuels that power our lives were created by the sun. But our increased use of fossil fuels seems to be upsetting the balance between the sun and the Earth.
Since all living material gets its energy initially from the sun is the source of the fossil fuels, whether it's trees, whether it's other things that have been trapped in the rock layer. and then squeezed and slowly over millions of years made into the hydrocarbons that we know them as. And we then harvest and use those from underground.
The fossil fuels that we burn today unleash the sun's energy from millions of years ago, overwhelming the balance struck between our planet and its nearest star.
If we burn all this, we will have changed the atmosphere unrecognizably long before we get to a point when we're actually running out of the resource itself.
Already, we have seen the effects of too much solar energy in the rise of global temperatures. The release of millions of tons of ancient solar energy stored in fossil fuels has amplified the necessary and natural process called the greenhouse effect.
Many people think that the greenhouse effect is a bad thing. Well, in fact, it's not. It keeps the Earth warm. Without the greenhouse effect, Earth's oceans would be frozen solid. What is bad is too much of a greenhouse effect. If there's too much carbon dioxide and water vapor and methane in the Earth's atmosphere, then those gases trap too much of the sun's radiation, elevating Earth's average temperature, leading to global warming. Now that can cause a melting of the polar caps and a rise in the ocean levels, leading to just a calamity on Earth if it happens too quickly.
Not only will our atmosphere continue to trap more heat, it could start to decay. Continued use of fossilized solar energy will allow in undesirable amounts of radiation from our sun. Right now, our ozone layer prevents the majority of the sun's ultraviolet radiation from reaching Earth, while allowing just enough sunlight to give us what we need to survive.
Sunlight interacting with our skin produces vitamin D, which is a very useful vitamin.
Vitamin D can protect us from a number of diseases, including the bone disorder osteoporosis and heart disease. But here, too, a balance has been struck. Too much sun can alter our DNA, causing skin cancer. Maintaining the equilibrium between sun and Earth that allows life to thrive will require using less of the sun's ancient energy and more of the energy it delivers on a daily basis. After all, the sun's energy output is estimated to be 386 billion megawatts. Meaning in 15 minutes, our star radiates as much energy as all life on Earth consumes in 1 year. Tapping this power source has been the goal of scientists for decades.
For sheer size, a solar satellite would be unprecedented. A structure 35 to 40 square miles covered with solar cells, able to capture the sun's energy 24 hours a day and beam it to Earth.
NASA has yet to achieve a goal on that scale, but their work with solar technologies in space has advanced technology here on Earth.
History of solar cells is essentially a technology that came back down to Earth from space. When we first started to work on the Apollo and Mercury and Gemini programs, we needed power plants in space. Solar cells were a natural way to do that.
Currently, we have two ways of directly harnessing the sun's energy. Solar thermal, which converts the sun's energy into heat by concentrating it enough to drive turbines, and solar panels, which use silicon-based technology to directly convert the energy from above into electricity. We can indirectly tap into the sun's power through wind turbines, capturing the energy produced by the weather the sun helps create. These technologies are constantly being improved. But some of the most interesting new science is coming from a very old process, photosynthesis.
There's some really exciting opportunities as we move from the world of semiconductor solar cells to organic ones.
Attempting to mimic Mother Nature, scientists have been able to create electricity from something found at the farmer's market, spinach.
There's organic molecules in spinach, in all green plants, but spinach happens to have a very convenient one, where you can harvest that peptide, that molecule.
Researchers were then able to put that peptide into a kind of solar sandwich, placing it between two electrically conductive materials.
And when it's exposed to sunlight, it will circulate electrons, which is current, which is electricity. So these organic molecules can actually become little solar cells.
In order to maintain the balance between Earth and our nearest star, it's become clear we must focus on finding ways to fuel our lives with the energy the sun supplies today. After all, the promise of solar energy is that for as long as the sun shines, its power can be ours. But what will happen when its power becomes too plentiful? The elements that make up the sun, the Earth, and even humankind all come from one place: stardust. The remains of stars that lived billions of years ago. And just as those stars died, so too will our sun.
In about 5 billion years, the sun will pretty rapidly become much more powerful, much brighter, and much bigger.
The sun will reach a stage where it has burned through all of its hydrogen. And once that happens, it will start to burn through all of its helium.
The sun will start to expand as it reaches a stage called a red giant. As it expands, it will start to expand into much larger size and fill the inner solar system.
The orbits of the planets themselves will actually expand outward as well, because it's not as massive.
During that stage, some instabilities, which I call cosmic burps, will cause the sun's outer atmosphere to be gently ejected.
The outer layers of the red giant will just keep drifting off at some slow rate.
The hot inner layers of the sun will ionize that cloud of gas surrounding it and cause it to glow. So our sun will be surrounded by these glowing clouds of gas.
They will form what's called a planetary nebulae. They're beautiful shapes. Some are just purely round, but some have been distorted into other shapes. They've come off non-symmetrically from the star underneath.
What'll remain is the contracting core of our sun. And it won't produce any new energy through nuclear reactions, because all the nuclear reactions will have stopped. So it'll continue contracting and slowly fading with time.
It's very similar to the process that creates, say, supernova, but our sun is not big enough, doesn't have enough stuff to actually create a supernova. So its final stage will be this object we call a white dwarf star.
What remains is this little, relatively small white dwarf star, and it is a very quiet, what we call happily retired star.
It'll be about the size of the Earth, it won't get any smaller, and it'll sit around as this very highly compressed rock forever. It'll just liberate its energy, growing ever colder and dimmer with time, until finally it just fades from view.
The death of the sun will have catastrophic effects on the solar system. If the massive expansion doesn't swallow the nearby planets, it will likely change their orbits and superheat them, including Earth.
Earth's surface will be fried to a crisp.
The Earth is probably going to get baked one way or the other.
I mean, imagine the sun being 100 or 200 times brighter than it is right now. Imagine how much the Earth would be heated. It would not be a pleasant place to be.
It actually may get baked before the sun completely dies, because the sun will get hotter even before it becomes a red giant and gets as large as the orbit of the Earth. It'll get warmer, and at some point the Earth will get hot enough so that water will boil.
So the oceans will evaporate away, and all of life as we know it will cease to exist.
If there's anything left of the Earth, the sun will shrink down to a white dwarf, and the Earth will, instead of heating, freeze.
This will not be a pleasant place to live.
But that's billions and billions of years from now. We've only had rockets in space, satellites, for 50 years or so. Now we're talking billions. So clearly we'll be able to travel around the solar system at the very least, to go to places that will be at the temperature that the Earth is now, and we'll be able by that time to go to more distant solar systems. So I don't spend a lot of time worrying about what's going to happen to the sun in 5 billion years.
The sun gave us our life, and it will eventually take it away. And though the Earth will die, it and everything on it will, in some part, live on. The stardust that gave Earth and all of its inhabitants life will one day become the stardust that gives rise to a new generation of planets, stars, and life.
So indeed, we are stardust. The carbon in your cells, the oxygen that you breathe, the calcium in your bones, the iron in your red blood cells. All those elements were created deep inside stars through nuclear reactions. And because some of those stars explode, we eventually are able to exist. The realization that we came from the stars is one of the greatest discoveries ever in all of science.